So today we're going to talk a little bit about the chain rule using a U substitution along with trig. And I have a couple examples at the end. We're going to take one rather large example and work our way through it with U substitution, and then do two examples, a more quick method. When we see a function buried within a function, in fact, you see here we have this mess cubed, and I show the 3 on the side coming out here. We have a whole lot of stuff here. So we have a function to the third power, and inside here is a whole nother function. Inside that's another, and inside that's another. So we're going to have to substitute 4 times this time. And we're going to use the chain rule. The derivative of f of g of x is equal to f prime g of x times g prime of x, and we're going to do that 4 times. Now again, we start with y equals this inside to the cube. Well, I'm going to set this stuff right here equal to u. And if I do that, I can write this at the top of the board. Y equals u cubed, u equals sine of tangent x cubed. So again, using differentials, this is not too bad. We can say derivative of y is 1 dy, derivative of u cubed is 3u squared du. But I don't want dy du if I divide it by du. I want dy dx. So I'm going to have to take the derivative of u over here and get du equals, but I don't know the derivative of sine of tangent x cubed. I know the derivative of sine x. So I'm going to say, let's let v equal tangent of x cubed. So I can write u equals sine of v. Well, that I know the derivative of. 1 du equals, derivative of sine is cosine v dv. Alright. I'll take the time to put that in over here. 3u squared. du is equivalent to this. But here's the problem. It's not dy dx yet. It's still dy dv. So I have to take the derivative of v. But v equals tangent x cubed. I don't know the derivative of tangent x cubed. I only know the derivative of tangent x. So I'm going to say, let's let w equal x cubed. U, V, W. Here we go. 3 substitutions. W equals x cubed. So I can write V equals tangent x cubed. Alright, here I go. Derivative of V is 1 dV. Derivative of tangent is secant squared. And this should be W. Secant squared W dW. Now I can put that in over here. And I have dy equals 3u squared cosine v. dv is equal to this, secant squared w dw. But I get dy dw. I need dy dx. So I see it here, so I take the derivative of w here. This time I can take the derivative of this. Derivative of w is 1 dw equals derivative of x cubed is 3x squared dx. And if I write that out, dw is 3x squared dx. And now if I divide both sides by dx, I get dy dx. And you notice this is one product. The chain rule is going to end up with one product. Now each of these things might be sums, but they'll be one product. So I can write this as dy dx by dividing that. So I'm going to do that in the next board. And write dy dx equals 3u squared cosine v secant squared w times 3x squared. And I know u, v, and w. Alright? So if I plug those in, 3, and then u squared is sine of tangent x cubed squared times cosine of tangent x cubed, that's v, times, and I'm going to have to go another line, secant squared w, which is x cubed, times, and we had the 3x squared. And now I have the derivative of dy dx. Again, often I don't want to do this on a test or on the AP test. I have to be able to do it from this function. So let's walk through the logic there and practice that logic on 2 problems. You have to see the cube outside and start by saying, I'm going to take the 3 power down and reduce it by 1, not changing anything inside. So I write y prime equals 3 sine squared reduced by 1. The argument inside must stay the same. Then you have to say, and often this is one of the myths, well, I haven't taken the derivative of sine yet. I've reduced its power, so now the derivative of sine is cosine. The argument doesn't change. Now I'm going to work here and look here and say, well, alright, now I can step inside because I did do the derivative of sine. What's the derivative of tangent? Well, the derivative of tangent is secant squared. Don't change the argument, it's x cubed. Finally, I can say, derivative of x, 3x cubed is x squared. And I've worked my way from the outside in. Alright? And that's what I'm going to do on these problems. So we'll start with this. You can pause and try this. Y equals cosine squared sine of x to the fourth. So y prime, or dy dx, is equal to, bring the power down, 2 cosine, 1 power, I won't write the 1, sine x to the fourth. There's the first step, times. I have to take the derivative of cosine, which is negative sine, and the inside stays the same. That argument, sine x to the fourth. Now I can step inside and say derivative of sine is cosine. And finally step inside, and derivative of x to the fourth is 4x cubed. And that's the derivative. On the next one I have kind of a mixture of a polynomial and an algebraic function here to the fifth power. So again, start by bringing the power down, 5. Inside does not change. That u would be that, so it would not change. Reduced by 1. Now we go inside and take the derivative of the inside. Alright. Derivative of x to the fourth is 4x cubed plus. Now this is the one's more complicated. I have to deal this with the chain rule. Well, I look at it, no power, so I can say the derivative of cosine is negative sine, so I'll change the sign, negative sine, and the argument doesn't change. Then I have to take the derivative of the argument, 3x squared is 6x. And that is the derivative of that function. Chain rule takes practice, keep practicing, alright? AP takes studying.